Hi everyone, so my name is Nilson Cortez, and in behalf with my fellow co-members, Joshua Bagalihog and Neil Brian Baroon, I will discuss to you guys the types of maps. But first, we must know what is maps. A map is a symbolic depiction emphasizing relationships between elements of some space, such as objects, regions, or themes. Maps present information about the world in a simple visual way. They teach about the world by showing sizes and shapes of countries, location of features, and distances between places. Maps can show distribution of things over Earth, such as settlement patterns. They can show exact locations of houses and streets in a city neighborhood. So why study the types of maps? Maps support spatial thinking by helping children visualize where objects, places, cities, and countries are in relation to one another. Spatial thinking has been linked to greater success in math and science. The field of geography relies on many different types of maps in order to study the features of the Earth. Some maps are so common that a child would recognize them, while others are used only by professionals in specialized fields. Different types of maps enable scientists to display detailed three-dimensional information about the surface and below-surface features of Earth. So what are the types of maps? The first one is the topographic maps. Topographic maps are a summary of the landscape and show important physical features in an area. The primary difference is that they show in elevation in detail. It is also one of the widely used maps. Topographic maps show the surface features of the Earth. Most topographic maps show both natural features such as rivers and hills and constructed features such as buildings and roads. It is made by using both aerial photographs and survey points collected in the field. A topographic maps show the elevation or height above sea level of the land. Elevation is measured from mean sea level, the point midway between the highest and lowest tide levels of the ocean. The elevation at mean sea level is 0. Understanding contours. Elevation is usually shown using contour lines. In simplistic terms, a contour line is a line which joins points of equal elevation. Where these lines are above sea level, they are simply called contour lines, and where they are below sea level, they are called bathymetric contour lines. Contour lines can tell an informed reader many things about the shape of the land and its ruggedness. The closer contours are together, the steeper the land, and the further they are away from each other, the flatter the land. The difference in elevation between one contour line and the next is called the contour interval. A cartographer chooses a contour interval suited to the scale of the map and the relief of the land. Relief is the difference in elevation between the highest and lowest points of the area being mapped. To make reading the map easier, a cartographer makes a very fifth contour line bolder than the 4 lines on each side of it. These bold lines called index contours that are labeled by elevation. A point between two contour lines has an elevation between the elevation of the two lines. Topographic map symbols. Symbols are used to show certain features on topographic maps. Symbol color indicates the type of feature. For example, constructed features such as buildings, boundaries, roads, and railroads are generally shown in black. Major highways are shown in red, while bodies of water are shown in blue, and forested areas are shown in green. Contour lines are brown or black. Often areas whose map information has been updated based on aerial photography but not verified by field exploration are shown in purple. So here are examples of topographic maps. Geologic maps. Geologic maps are maps that depict the rock units that crop out at Earth's surface. Typically, they use different colors or different field patterns to distinguish between different geologic units or formations. Units, members, formations, groups, supergroups, and etc. meet at contacts which can be of several varieties. To make relationships between rock units more clear, many geologic maps include cross-sections, which show a conceptual slice through the Earth along a straight line or multi-segment polyline on the map. The patterns that rock units formations make can convey key information about the geologic history of a region. Geologic maps are uniquely suited to solving problems involving Earth, resources, hazards, and environments. Geologic maps represent the distribution of different types of rock and surficial deposits as well as locations of geologic structures such as faults and folds. Geologic maps are the primary source of information for various aspects of land use, planning, including the seating of buildings and transportation systems. Elements of geologic maps. A base map, usually a topographic map of the region. Topographic maps depicts the shape of the land using contour lines of a set elevation. The usual stuff that goes along with the topographic base map, such as scale, a reference map, latitude and longitude, and magnetic declination, the angle of difference between magnetic north or geographic north. Distinct geologic units differentiated from one another by some distinction like different colors or different fill patterns, as well as an abbreviated identifier code. For instance, the Cambrian Age Weaverton Formation might be a tan in color and would be abbreviated as EW. Contacts between different geologic formations. These contacts might be conformable stratigraphic contacts, unconformities, faults, or intrusions. Symbols showing the measured orientation of rock structures such as bedding, foliation, and faults. Other symbols showing the interpreted structure of the region such as anticlinus, synclinus, normal faults, thrust faults, and transform faults. Orientation of structure. Knowing the position of geologic structures is important for geologic mapping. These structures include sedimentary features such as beds, metamorphic features such as foliation, and igneous features such as dikes. Their position in space can be measured in the field and recorded accurately on the map using symbols and numbers. Other markings on geologic maps are contact lines. A contact line indicates places at which two geologic units meet, called contacts. The two main types of contacts are fault and depositional contacts. Depositional contacts show where one rock layer formed above another, while faults are cracks where rocks have moved past each other. Also on geologic maps are strike and dip symbols for rock beds. Strike indicates the direction in which the beds run, and dip indicates the angle at which the beds tilt. So here are examples of geologic map of India. Soil map. A soil survey consists of three main parts: text, maps, and tables. The text of soil surveys includes general information about the geology, topography, and climate of the area being mapped. The tables describe the types and volumes of soils in the area. Soil surveys generally include two types of soil map. Soil map is a geographical representation showing diversity of soil types and or soil properties in the area of interest. It is typically the end result of a soil survey inventory. Example, soil survey. Soil maps are most commonly used for land evaluation, spatial planning, agricultural extension, environmental protection, and similar projects. Traditional soil maps typically show only the general distribution of soils, accompanied by the soil survey report. Many new soil maps are derived using digital soil mapping techniques. Such maps are typically richer in context and show higher spatial detail than traditional soil maps. Soil maps produced using geo-statistical techniques also include an estimate of the model uncertainty. Soil maps are valuable tools for agriculture and land management. Knowing the properties of the soil in an area helps farmers, agricultural engineers, and government agencies identify ways to conserve and use soil and to plan sites for future development. Here are an example of soil map of Australia. Other types of maps. Earth scientists also use maps to show the location and flow of both water and air. These maps are commonly constructed by plotting data from various points around the region and then using isograms to connect the points whose data are identical. Maps are also used to show the locations of areas of high and low air pressure and the weather fronts that move across Earth's surface. These maps are updated constantly and are used by meteorologists to communicate to the public important information on daily weather conditions and emergency situations. So here are some examples of other types of maps. Weather maps. People use an incredible number of weather maps. They are used to show predicted temperatures, predicted precipitation, storm warnings of various kinds, wind speed and direction, chances of precipitation, type of precipitation, snow accumulation, frost prediction, and many other aspects of weather. All of these weather maps are continuously updated to communicate the most current information. They are the world's most frequently consulted thematic maps. Weather maps are presented in newspapers, television programs, and especially on websites. Delivering weather maps on websites and through web apps gives people around the world instant access to weather information. Many weather maps are animated maps that show historical or projected changes in the weather. These are extremely useful for people who need to know how changes in weather will impact their travel, workday, recreation, and many other plans. Physical maps. Physical maps are designed to show the natural landscape features of Earth. They are best known for showing topography either by colors or as shaded relief. Physical maps often have a green to brown to gray color scheme for showing the elevation of the land. Darker greens are used for near sea level elevations, with the color grading into tans and browns as elevation increase. The color gradient often terminates in shades of gray for the highest elevations. Rivers, lakes, seas, and oceans are usually shown in blue, often with the light blue color for the most shallow areas and darkening in a gradient or by intervals for areas of deeper water. Glaciers and ice caps are shown in white colors. Physical maps usually shows the most important political boundaries, such as state and country boundaries. Major cities and major roads are often shown. This cultural information is not the focus of a physical map, but it is often included for geographic reference and to increase the utility of the map for many users. And lastly, political maps. Political maps are among the most widely used reference map. They are mounted on the walls of classrooms throughout the world. They show the geographic boundaries between governmental units such as countries, states, and countries. They show roads, cities, and major water features such as oceans, rivers, and lakes. Political maps help people understand the geography of the world. They are usually the first type of map that students are introduced to in school. They are also known as reference map because people refer to them again and again as they have questions. So that would be all for today's discussion, the types of maps. So thank you for listening and hope you learned something from me. Thank you.